So this is our final lesson of the unit. It's probably everyone's favorite, proving trigonometric identities. So you've done this in grade 11, and we're just doing it again in grade 12, but this time around we have a lot more tools, a lot more identities to help us out. So unfortunately that means that the identities we're proving in grade 12 will be a little more complicated than the ones you've worked in grade 11. But the good news is that you have the foundation. You know the idea of what it means to be an identity. Just in case you forgot, I'll show you what an identity is. So let's do it right over here. 2 plus x equals x plus 1 plus 1. I know this looks strange, but that is an identity, okay? Because, oh, whoops, that is not an identity. Oh, that's perfect, it works out. This is not an identity. So what does it mean to be an identity? If both sides are defined, then they will be equal, okay? So I made a careless mistake there. I meant to say 2x, okay? So regardless of what you let x equal, both sides will be equal. So you can let x equal 1 and do the math. Let x equals 2, let x equal 3. But unfortunately, you can't let x equal a string of numbers and then say you have an identity, okay? Because there are infinite values that x can take on. So to prove an identity, it generally requires you to use some algebraic manipulation. Now, if it's trigonometric identities, then you'll use simple identities to prove more complicated identities, okay? But nonetheless, an identity is a special equation, which is always true as long as both sides are defined. That both sides are defined part is really important. So I'll show you what I mean by that. So if in grade 11 you might have seen tan theta E times cos theta equals sine theta. Okay, so you would say left side is equal to tan theta cos theta, and then tan theta is sine theta over cos theta because of our quotient identity, and then it's sine theta okay. So you have shown that tan theta times cos theta is equal to sine theta, and that means it's an identity. But be careful. If I let theta equal pi over 2, what's tan of pi over 2? Tan of pi over 2 is undefined, okay? We learned that earlier. Tan of pi over 2 is undefined. So if the left side or the right side happens to be undefined, of course we can't say left side equals right side. So when they are both defined, they will be equal. Okay, that's what an identity means. But if one side is not defined, then obviously you can't say they're going to be equal. That's a super small detail. But nonetheless, an identity is an equation which is always true as long as both sides are defined. So let's look at all the identities we can use to help us out. So we have reciprocal identities from grade 11, the Pythagorean identities from grade 11. So there's 3 different versions. They will come in handy to know. It will come in handy to know all 3 versions of it. Quotient identities, tan theta equals sine theta over cos theta, which means cotan theta is cos theta over sine theta. Now, what did we learn this year? We learned that sine and tan are odd functions, and cosine is an even function. We did cofunction identities, which allow us to go from sine to cos, or cos to sine, cosecant to secant, secant to cosecant, tan to cotan, and cotan to tan. We did the addition and subtraction formula for sine, cos, and tan, which leads us to the double angle formulas for sine, cos, and tan. Now, what I don't have on this piece of paper are the half angle formulas, but you can write them down if you want. And then we also have triple angle formulas. Okay. The reason why I didn't write the half angle formulas because those were some bonus identities for you. And the triple angle formulas are also bonuses, but you can prove these to yourself because the triple angle formulas are derived from the double angle formulas. Okay, I believe that's one of the homework questions. All right, you know what? Let's prove some identities. Fun stuff. So when you prove an identity, you always pick the side that is more complicated. Okay, so it's much easier to prove something that's complicated or work with something that's complicated and make it simple as opposed to something that's already simple and make it complicated. So for example, you look at C and E, like I would never work with the right hand side because if it's cotan x, I have too many options, right? There's just too many paths I can take, and I might not find the most efficient way of getting the right side to be the same as the left side. It's much easier just to work with a complicated side. I know it sounds counterintuitive, but once you do more practice with identities, it will seem very logical to pick the more complicated side. All right, so the more complicated side is the left side. So sine of x plus y, sine of x minus y. So you need to know the addition formula and you need to know the subtraction formula for sine. So subtraction formula for sine is sine x cos y minus sine y cos x. These terms are the same, so it's a difference of squares. So sine squared x cos squared y minus sine squared y cos squared x. So if you look on the right side, what you're trying to prove, I don't see a single cosine function here. So these coses have to disappear. So that's a trick with proving identities. You have to basically keep an eye on the left side and keep an eye on the right side and try to make them the same. But seeing what you're trying to get to really helps you. And the number one rule of proving identities, well, I'd say there are two big rules. The number one rule is you need to memorize your identities. So if you don't know your compound angle formulas, your double angle formulas, you have to memorize them, okay? Otherwise, identities will be very challenging because you don't know the tools at your disposal. The second big rule to proving identities is don't make up stuff. You cannot, you can't make up your own rules. You have to follow the basic algebraic rules that you learned from grade 9, 10, and 11. You can't all of a sudden abandon difference of squares, okay? Your expansion, all that stuff is still true. Okay, so with all that being said, cos squared y and cos squared x have to disappear using the Pythagorean identity from grade 11. Perfect. So I don't see a single cosine function. I am stoked. And what do you know? It works out beautifully. So once we've achieved our goal, QED. QED stands for, oh my Latin's not good at all, Code Erat Demonstratum. You know, I Google it'll be so much better. But it's basically saying we've shown what they've asked us to show, which means we have an identity, okay? This is indeed an identity. And by the way, if we ask you to prove an identity, it's certainly an identity. We're not going to trick you, okay? That wouldn't be very nice. All right. For part B, I'm going to work with the right side. And you have to know your addition and subtraction formula for cosine. If you don't have them memorized, please go memorize them. I still really want to redeem myself. I butchered QED so bad. Alright, simplify that. Oh, that was not bad at all. 2 cos x cos y. code erat demonstrandum. I think that was much better than the first try. Okay, I forgot to mention, if you're really struggling with proving identities on the test, then what you can do is work with the left side and then pause and then work with the right side and make them meet in halfway. What you cannot do is manipulate both sides at the same time. For example, like when you try to solve an equation, you can't multiply both sides by 4 when you're proving identities. You can't divide both sides by 6 or do the things that you would regularly do when you solve an equation. But for all the examples, the 6 examples I'm doing on this page, I'm just going to prove them just by working with one side. So for part C, I'm going to work with the left side, the more complicated side. So once I saw left side, I know I need to know my double angle formulas, because if I don't know them, this would be very hard to prove. And by the way, this is actually very interesting because from here I can generate the half angle formula for cotan. Anyways, that's just a side note. I was gonna say make a bad joke. I hope you can see what I was gonna say. Sine 2x, 2 sine x cos x, cos 2x. Now there are 3 versions. I see a 1 over here that I really don't want to see because I want to cancel common factors, and I can't do that with a 1 there. So I'm going to use a 1 minus 2 sine squared x version. Okay. We have an identity. Okay, let's do D. So I'm going to work with the left side. So you could use the subtraction formula for sine and the addition formula for tan. But I'm going to use, instead, I'm going to use equivalent trig expressions. I know sine of pi minus x must be equal to sine of x because the reference angle of pi minus x is x. So, and this is in the second quadrant, so sine of pi minus x must be sine x. And tan of pi plus x, that's in the third quadrant with the reference angle of x. And third quadrant, tan is positive. If that was too much for you, if you didn't see the equivalent trig expressions, then quite simply use the compound angle formulas and you'll get the exact same thing. But you'll have you'll have a big step in between here. Anyways, I'm going to simplify. I see 2 terms essentially. I want to simplify into a single term. So common denominator. So tan x is sine x over cos x, our quotient identity from grade 11. The lowest common denominator is cos x. In the numerator, I'm going to factor out sine x, and I'm done. Okay, 2 more to go. I can't stress this enough. You need to memorize your identities. Alright, left side. So I'm going to break this apart. So cosecant 2x is 1 over sine 2x. Tan x is sine x over cos x. And secant x is 1 over cos x. Okay, let's clean this up a little more. So we divide by 1 over cos x, that's essentially multiplying by cos x. So I'm going to write cos x over 1. Now sine x over cos x, I'm going to leave that alone. But sine 2x, I'm not going to write sine 2x because I know the double angle formula for sine. So that's 2 sine x cos x. So now I'm going to cancel out my common factors. So 1 over cos x is what remains. And of course, 1 over cos x is secant x. Mission accomplished. QED. Alright, one more to go. So when I take a look at this, I'm definitely working with the left side. Cos of x minus y. Cos x sine y. Alright, the numerator, right away I see the subtraction formula for cosine. And the right side, I see two terms. So I need to create two terms from what I have right here. So basically I can see one fraction, I'll break it apart as two fractions. So cos x cos y over cos x sine y plus sine x sine y over cos x sine y. Cancel out the common factors. So you're left with cos y over sine y plus sine x over cos x. So that's cotan y plus tan x. Hey, what do you know? That's the right side. QED. So this lesson is very nice because it puts together everything we've done. We learned some cofunction identities, double angle, half angle, compound angles. So with all those tools, you can prove the identities. And that is the end of chapter 4.